Find the acceleration of the body M relative to the horizontal surface on which the wedge slides. That means हमें with respect to the stationary ground बताना है और not with respect to the wedge. So इसमें relative acceleration नहीं निकालना है, with respect to ground निकालना है, यानी कि inertial observer. Let's mark the FBD for this small m. इस पे वेट नीचे लगेगा mg और क्योंकि नीचे स्लाइड करेगा फ्रिक्शन ऊपर लगेगा F. देन ये वेज का रिएक्शन इधर लगेगा राइट साइड में N. टेंशन T ऊपर लगेगा. So these are the forces acting, and since this is the only force, it must move in the forward direction. We can write ma, and also it is moving in the downward direction as ma. So let's make the FBT for the equations for this. Mg minus T minus F is equals to ma. I hope we are not forgetting any other force to mark. Friction we have marked, tension we have marked, Mg we have marked, and N we have marked. Yes. So we can also write Mg minus T, F is mu N is equals to ma. For Mg minus T minus mu ma, because this is another equation, N equals to ma. So we can replace N with ma and we get Mg minus T is equals to ma 1 plus mu. So we can write Mg minus T upon m 1 plus mu as a. This is the acceleration we have got. Since it is falling down as well as moving right with the same accelerations, because the two blocks are connected to the same string, they cannot have different accelerations. So final answer would be a root 2, because they are perpendicular to each other. This is a, this is a. We get a root 2 is the net acceleration, which we have to give with respect to the ground. So once we find the value for t, we can get the answer. Just multiply this entire function by root 2. So to find out t, let's make the FBT for this block, bigger wedge. This is mg. There are one tension in the right direction and one tension in the upward direction. With the pulley, there are two tensions in the downward direction. We can add 2t here. And since this block moving downwards, the friction on small m acts upwards and on the wedge acts downwards. So another we can write F. Remember that, not to forget that there is a normal force like this here as a reaction to this N on the small m block. And now these are moving, this is also moving in the right direction, capital M into A. There is another force in the upward direction, let me call it N dash. Now we know that these two forces, two forces upwards and one collection of three forces downwards, will balance each other. However, we are not concerned about this direction. Motion is taking place in this direction. Let's only write the equation for the right hand side. So T minus N is equals to ma. So we have got T, as we wanted T here only, N we already have N as ma. So we have T equals to a m plus m. Now let's put it here and we get mg minus T is a m plus m. Let's take it there only, because a has to be solved. M plus m is equals to m a m 1 plus mu. So we have mg upon m plus n, that is 2m, plus 1 will be mu m and 1 will be capital M as equals to a. Since we need a root 2, please you can also solve it. Maybe you are not able to solve it in one line, you can take 2 to 3 lines to solve it. And we actually want root 2, so we put root 2 here, and that is the final answer to our question.